Hi, welcome back, and let's discuss wired devices. So probably the most common wired device to interconnect devices is what's commonly called a network cable, and it looks a little bit like this. Now the official name is Unshielded Twisted Pair, or UTP for short. And if we were to grab a UTP cable, cut it in half, and then peel the outer layer back, it would look a little bit like this, and that helps explain the twisted part in the name. There are a couple of variations of cables known as categories, and you might hear people saying, oh, that's a Cat5 cable or Cat6 cable or different variations like that. And the main difference between those categories is going to be the bandwidth that it supports. Now, if there's an unshielded cable, does that also mean that there's a shielded type? And the answer is yes. There's a shielded twisted pair, or STP for short, and it looks a little bit like this. So it's very similar to the UTP cable, but as you can see, it does have additional wrapping, and this is to provide better protection from electromagnetic interference, or EMI, that could come from things like electric cables. Now, the maximum distance recommended for UTP and STP depend mostly on the quality of the wire, but the international standard states that the maximum distance should be 100 meters, or about 328 feet. Longer than that, and you'll likely experience degradation on your service, which would mean things like packet loss and high latency. So if UTP and STP cables can only be used in shorter distances, and wireless links also can't be used for very long distances, what options do we have for those very long distances? How are we able to connect to devices that are on a completely different side of the planet? This is where our friend, the fiber optic, enters the game. The other links use electrical pulses regardless of whether we're talking about wired or wireless to send data. But fiber optic uses light. It's very, very thin, and it's a hollowed wire that transports light pulses. So how far can fiber optic go? Well, let's take a look at something. Each one of these lines is an underwater fiber optic cable. They literally interconnect the world. They go all the way to the bottom of the ocean, and while they do have to use amplifiers at regular intervals, since distances are so insanely long, these amplifiers can be several kilometers or miles apart. And each one of those points on the map is called a landing point. That's where the submarine cables come to the surface. It's in these landing points where different service providers can take over and start to distribute the internet using their own fiber optic networks on land. That then branches out to other states, to counties, to buildings, houses, etc., which is then connected to your home router or a business router. Then you connect to this router, like we said before, using wireless or Wi-Fi, or wired using UTP or STP cables. And so now we can see how it all starts to fit together. Now, fiber optic has four major benefits. Number one, like we said, you can use it for very long distances. There are a number of different types of fiber optic cables, so it depends on which one you're using. It also depends on the power of the transmitter and several other factors. And just like in wireless links, designing a fiber optic network is an entire area of specialization since it can become very complex. And number two, since fiber optic uses light, it's not affected by electromagnetic interference, unlike with wireless and wired technologies. Number three is bandwidth, which is the amount of data that it can carry. Fiber optic can support a tremendous amount of bandwidth. Imagine how much is needed in order to handle intercontinental traffic, which is an absolutely mind-boggling amount of data. And then number four is latency, which is how fast data travels. All that bandwidth in the world would be almost useless if data traveled slowly. And since fiber optic uses light, it means that the information can travel insanely fast. And this is what allows us to access information that could be in a completely different continent, not in a matter of seconds, but in less than a second, literally talking about milliseconds. In fact, let's go ahead and do a quick test and let's see how fast this can be. If you're using Windows, you can follow these steps by first going to the Windows search tool, then typing CMD to select the command prompt app. We can type ping www.cyber.com and then we can hit enter, and you'll see an output similar to this. Now, your data may look a little bit differently, your time might be different, your TTL number might be different, but overall this will look the same. Ping is a command that allows us to do a very basic connectivity test to some servers, and it works by sending a small packet to which the server replies to. It's pretty much like asking the server, hey, are you there? And the server replies with, yes, here I am. And in this case, we're trying to contact the cyber.com server. So let's analyze some parts of this output. We're pinging www.cyber.com. We see a public IP address, and this is the IP address that cyber.com servers are using. And we will talk about IPs later on in this course. And then we see a reply from that IP address. We can see the bytes, we can see the time, and we can see a TTL number. This is the round trip time of the sent packet. This means that the packet in this case took roughly 70 milliseconds to go back and forth to the cyber.com server. And 70 milliseconds, as you know, is 0.07 seconds, which is literally faster than blinking. Now bear in mind that this is the response time from my personal computer. For you, it could be a little bit faster or a little bit slower, depending on how far you are to the server you're testing and even your type of connection. For example, if you're using Wi-Fi or if someone is clogging up your internet connection, this might impact the time. Or if the server is based in North America and you are based in India, that's a much further distance to travel than for somebody else who is based in the United States. But either way, it should still be extremely fast unless there's a problem with the internet or with the server. But that's it for this lesson. Let's go ahead and wrap it up. And in the next lesson, we'll start to look at layer 2 and the OSI model.